Hi, hello, welcome to Homeschool. This is your class 9 mathematics NCERT or CBSE board. We are in our 5th chapter, triangles. Before starting your next exercise, we are going to deal 2 rules. What are those? Theorem 5.4 SSS congruence rule. What is SSS? Side congruence rule. If 3 sides of one triangle are equal to the 3 sides of another triangle, then the 2 triangles are congruent. Let us take an example here. A, B, C, D, E, F. How can we prove this theorem? If we take 2 triangles such that 3, 5, 6 centimeters. On comparing 2 triangles, what we can say? AB equal to DE, BC is equal to EF, and CA is equal to DF. The corresponding sides of 2 triangles are equal. If they are equal, therefore, the 2 triangles, triangle ABC is congruent to triangle DEF. By which rule? SSS congruency rule, we can say that the 2 triangles are congruent. Suppose if the corresponding sides of 2 triangles are equal, we can say that by SSS rule they are congruent. One more theorem. Theorem 5.5 RHS congruence rule. RHS full form right angle hypotenuse side. If you have 2 triangles, we are talking about right angle. So let me take a right angled triangles. Now A, B, C, P, Q, R. Let us consider 2 triangles, 2 right triangles ABC and PQR, where angle B is equal to angle Q is equal to 90 degree. And this is the hypotenuse. Right angle opposite side is called as the hypotenuse, AC, PR. Sides BC, QR. Just I am saying the corresponding side. BC corresponding to QR, AB corresponding to PQ. But we don't know they are equal or not. If they give you like this, if any 2 triangles, if you come across like this, right angle and one side is equal and one pair of hypotenuse is equal, then you can prove these 2 triangles are congruent. That is, triangle ABC is congruent to triangle PQR by RHS rule. What is RHS? Right angle, hypotenuse, side. Statement. If in 2 right triangles, the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the another triangle, then the 2 triangles are congruent by RHS rule. Suppose in your problems, when you come across 2 triangles, when you are comparing the 2 triangles, if you are able to see right angle hypotenuse side is equal to the corresponding triangle, then what you can say? Those 2 triangles are congruent. Let's start our exercise 5.3. First problem. Triangle ABC and triangle DBC are 2 isosceles triangles on the same base BC. Observe here, this is a base BC. ABC triangle and DBC triangle lying on the same base. And what is this? A and D are on the same side of BC. If AD is extended to intersect BC at P, show that. There are 4 sub-questions here. What is your problem? They have given 2 isosceles triangles which are lying on the same base BC. Let me take here AB is equal to AC and BD is equal to DC. They have given their isosceles triangles lying on the same base BC. Let's start our solution. There are 4 sub-questions asked here. Let's start the solution with the given data. Given triangle ABC and triangle DBC. ABC and DBC are isosceles triangles on same base, lying on the same base BC. If they are isosceles, we will write here AB is equal to AC and BD is equal to BD or DB. You can AD is extended to intersect BC at P. To prove, what we need to prove? We need to prove 1, 2, 3, 4. Again, all sub questions you write here. What given in your question, you write all the sub questions. That means triangle ABD is congruent to triangle ACD. I need to prove. And your second one, triangle ABP congruent to triangle ACP. Third one, AP bisects angle A as well as angle D. And your fourth one, AP is the perpendicular bisector of BC. These are the 4 sub-questions we need to prove by seeing this figure. Let's start your first problem. Triangle ABD congruent to triangle ACD. I need to prove. I'm going to consider now. You can write in or consider anything. In triangle ABD and triangle ACD. Try to identify the 2 triangles here. ABD, ACD. Where is ABD? This part. ACD, this part. These 2 triangles, first compare here. What you can say? This side equal to this side. And this side equal to this side. And third side is common for 2 triangles. Then what you can say? Side, side, side. By SSS congruence rule, I can say the 2 triangles are congruent. That's all. That is the thing we need to prove. Let's write here. In triangle ABD and ACD, I say that AB is equal to AC. Given triangle ABC is an isosceles triangle, AB equal to AC. Next step. DB is equal to DC. This is also given in this triangle. Which triangle? BDC. It is also an isosceles triangle. Then the 2 sides are equal. Next one. AD is equal to AD. What is the reason? Common side. It is common side. Therefore, triangle ABD is congruent to triangle ACD. By which rule, children? By SSS congruence rule, I can say that the 2 triangles are congruent. That's all. See the second sub question. Triangle ABP congruent to triangle ACP. Observe here ABP, where it is? This triangle. ABP. ABP triangle is congruent to ACP triangle. I need to prove. Before proving this, I just observe here what all I know. I know only AB is equal to AC. And this is the common side. Then how can I prove this one? Okay, let me think a while. Before sub question, what I have proved? This triangle is congruent to this triangle. If these 2 triangles are congruent, by CPCT, what I can say? Corresponding parts of a congruent triangles are equal. Right? So, I can equate this angle equal to this angle. Fine. Now, next. Angle side I got. Then anything there? Yes. Let me remove this line for a while. Just remove this line for a while. Now, these two sides are equal. Then what do you remember? If two sides of an isosceles triangle are equal, then their opposite angles are equal. According to that, I say these two angles are equal. Now, observe the two triangles. Angle, side, angle. Angle, side, angle. By ASA congruency rule, I can say these two triangles are congruent. Ready? Let's prove this. We know that, we can start here. We know triangle ABD is congruent to triangle ACD by CPCT. Corresponding parts of a congruent triangle are equal. CPCT, what I can say? Angle BAP is equal to angle CAP. Right? By that congruency of two triangles, I have done this one. Now consider the triangles what we need to prove. Consider triangle ABP and triangle ACP. Now start comparing, children. AB is equal to AC. What you can say? Given isosceles triangle, they have given. And now, write this one. Angle BAP is equal to angle CAP. Already we have proved in the first sub question. So we write here proved. Next one. Angle ABC is equal to ABC or ABP, you can stop. Angle ABP is equal to angle ACP. Angle ABP is equal to angle ACP. What is the reason? Angles opposite to equal sides of a triangle, are equal. According to that, I have said these two angles are equal. Now by angle, side, angle, congruency rule, I can say triangle ABP is congruent to triangle ACP. By which rule? By angle, side, angle, congruency rule. Congruence rule, I say that these two triangles are congruent. See the third sub question. AP bisects angle A as well as angle D. What is this? This AP bisects angle A and angle D we need to prove. Look here, already angle A is bisected. I can say AP bisects angle A. If this angle equal to this angle, you can say that word. Then what about D? We should consider these two triangles and try to prove these two triangles are congruent. If they are congruent, then by CPCT you can equate these two angles and then you can say AP bisects angle D. We know triangle ABD is congruent to triangle ACD. Then if these two triangles are congruent, by CPCT you can equate these angles. Right here, by CPCT, angle BAD is equal to angle CAD. If these two angles are equal, what you can say? Therefore, AP bisects angle A. Second one, AP bisects angle D. How can I prove? I did not prove these two triangles congruent. So let us take this one. Consider triangle BDP and triangle CDP. In any way you can prove, children. First understand all rules, then any rule you can apply here. See here, isosceles triangle, these two sides are equal. And if these two sides are equal, their opposite angles are equal. Side angle, and this is a common side you have. I cannot say that SSA, I don't have any SSA rule. So which way I need to prove? If you are able to prove two sides are equal, then automatically remaining side will be equal. So when that is equal, then I can prove by SSS, congruency rule, the two triangles are congruent. If they are congruent, then the angles are equal. Let's see here, in triangle BDP and DPC or CDP, what I can say here? DB is equal to DC. In isosceles triangle, two sides are equal. They have given this. DP is equal to DP. Reason, it is a common side for two triangles. If two sides are equal, then the remaining side, what is that? BP is equal to CP. Remaining side is also equal. So, continue here. Remaining side is equal. Therefore, triangle BDP is congruent to triangle CDP. If these two triangles are congruent by CPCT, I can say that angle BDP is equal to angle CDP. If these two angles are equal, what you can say? Therefore, AP bisects angle D. That's all. That is only the proof for third sub-question. Fourth sub-question, AP is a perpendicular bisector of BC. AP is a perpendicular bisector of BC. Means what we need to prove? We need to prove this angle is 90. Perpendicular angle is 90. Either this angle 90 you can prove or this angle 90 you can prove. How can I prove this? I am going to consider again these two triangles. What I was able to prove there? Angle D is equal to angle D. I have proved before sub-question. And we know this angle equal to this angle. So if two angles are equal, automatically third angle will be equal. Right? Or you can say by ASA, congruency rule, these two triangles are similar. Or you can go with SSS, these two triangles are congruent. If they are congruent, by CPCT, I can equate remaining angles or sides. By that, I am going to equate these two. Let's start here. We know in triangle BDP and triangle CDP, we got there. So just directly I am going to write angle BDP is equal to angle CDP. By corresponding parts of a congruency triangles, I have proved already that one. If you want, you can write triangle BDP congruent to triangle CDP and you can write these two angles. Now, this BDP is equal to CDP we proved. Therefore, again by CPCT, what I can say, other angles I will equate. That is angle BPD is equal to angle CPD. Where is that angle? Angle BPD this one, angle CPD this one. This angle equal to this angle. But by linear pair axiom, what you can say? Linear pair axiom. I can say these two angles sum is 180. Write that one. Angle BPD plus angle CPD is equal to 180 degrees. We got BPD equal to CPD. Let us substitute. Instead of BPD, substitute. CPD plus angle CPD is equal to 180 degrees. Add this. 2 times angle CPD is equal to 180 degrees. And you can cancel 290s. So finally what you got? Just bring this side here. Therefore, angle CPD is equal to 90 degrees. Means this one I was able to prove 90. Then automatically angle BPD is also equal to 90 degrees. Therefore, AP is the perpendicular bisector of BC. AP is the perpendicular bisector of BC. That's all. There is a link between one triangle to another triangle while we are proving these sub-questions. Let's see once again this problem here. They have given two triangles ABC and BDC, two isosceles triangles lying on the same base BC. And what is this AD are on the same side of BC. If AD is extended to intersect BC at P, show that there are four sub-questions as first one, ABD congruent to ADC you need to prove. Then in isosceles triangle, two sides are equal. In isosceles triangle, these two sides are equal. In this triangle, ABD and ADC, they have already given AB equal to AC, isosceles triangle. And these two sides are also equal. These two sides are equal. How you can say? Another isosceles triangle. Sides equal and this side is common by SSS congruency rule. These two triangles are congruent. That's it. Then second one, ABP, ACP. ABP, ACP. How you can prove here? AB is equal to AC. And before triangles are congruent means then by CPCT these angles are equal we proved. And this angle is equal. And one more where we have taken, if these two sides are equal, these two angles are equal. By angle side angle congruence rule, we have proved these two triangles are similar. And third one, AP bisects angle A as well as angle D. How it is bisecting? If these two angles are equal, then we can say it is bisecting angle A. Actually, this one already proved. Directly you write that point there. By these two triangles are congruent and by CPCT these angles are equal. Now coming to D. How can I prove D? Consider these two triangles. These two sides equal, this is common side. If two sides of a corresponding triangles are equal, then automatically third side equal. You can equate BP equal to PC. By SSS congruency rule, these two triangles are congruent. If they are congruent, by CPCT, you can equate this angle equal to this angle. Therefore, AP bisects angle D. Last sub question. AP is a perpendicular bisector of BC. We need to prove. Perpendicular means angle 90 we need to prove. How can I prove this? I know these two triangles are congruent. If they are congruent by CPCT, angles are equal. If I need to prove it as a perpendicular, I take here bilinear pair axiom. The sum of the angles will be 180. Sum of the angles on a straight line will be 180. So this angle plus this angle is equal to 180. This equal to this already we have written. Substitute 2 times angle CPD is equal to 180. Angle CPD or angle BPD equal to 90 degrees. If you get 90, you can write off AP is a perpendicular bisector of BC. Second problem. AD is an altitude of an isosceles triangle ABC in which AB is equal to AC. We need to draw the figure. Draw a triangle ABC which is isosceles. AB equal to AC. And draw AD which is altitude. Right? Show that AD bisects BC. AD bisecting BC. How it will be bisected? If you are able to prove BD equal to DC, then I can say AD bisects BC. Second sub question. AD bisects angle A. AD bisects angle A means if this angle equal to this angle, if you are able to prove, you can prove this one. Right? First, we need to write the given data. Given ABC is an isosceles triangle. AD is altitude, right? In which AB equal to AC. AB equal to AC. Isosceles triangle AB equal to AC. Altitude is perpendicular. Now, what we need to prove? To prove, first one, AD bisects BC. And second one, AD bisects angle A. Proof. First, we need to prove that AD bisects BC. How I can say? If I am able to prove BD equal to DC, then I can say that one AD bisects BC. In or consider, you can say, consider triangle ABD right triangle. This is right angle, right? Consider right triangle ADB and right triangle ADC. Observe here carefully. Right angle, hypotenuse, and this is common side. By RHS congruence rule, I can say these two triangles are congruent. Now let's prove that one. Angle ADB is equal to angle ADC is equal to 90 degree. Given. Second, hypotenuse AB is equal to AC. This is also given, but we call it as hypotenuse. They have given us isosceles triangle, two sides are equal. AD is equal to AD, that is common. Therefore, triangle, right triangle means you can put this symbol. Right triangle ADB is congruent to right triangle ADC. By which congruency rule? Right angle hypotenuse side congruence rule. I can say that these two triangles are congruent. If they are congruent by CPCT, corresponding parts of a congruent triangles, other angles and other sides you can equate. So I need BD is equal to DC. If BD equal to DC, then what happens? Altitude is bisecting BC. Therefore, AD bisects BC. Therefore, AD bisects BC. AD bisects angle A. We know that what we got, children, here? Triangle ADB is congruent to triangle ADC. You can write here right triangle or normal triangle also you can write. We already proved that triangle ADB is congruent to triangle ADC. By CPCT, I may equate remaining angles also. Angle BAD is equal to angle CAD. Angle BAD is equal to angle CAD. Therefore, AD, these two angles are equal. Therefore, AD bisects angle A. Hence, it is proved. That's all we need to prove. And with this, we are going to end our session, children. In our next class, we are going to continue with this exercise. Until that, keep watching. Thank you all.